Hello, everybody. In this video, I did a presentation to talk about REST API, and I want to talk about what it is, how that actually works, and what are the beneficial to use them. And this start in order to be able to create our applications to actually pull and bring information in. Usually need to talk with other application itself that can do that for us. So in the traditional way of doing an app, we have we're talking about a desktop application or the way that we do it before. Actually, it's still being using. We have one application that have it all. What I mean is have the data layer that connects to databases or whatever persistence form of data it has. A layer where it transforms the information. It have the logic per se, and the layer to view that information to able to render it in a window or in a front end somehow. Now, through the web, that got converted with what is traditional called the MVC model, model view component. What it does is you have your model like your data layer, your views like your freshet and the controllers per se. I say component before. I'm sorry. It's actually model view controller. Then controller is the guy who tied it up, the data layer, and send it to the view layer. But it's still contained in one app. Through the future, in order to make things be able to scale easier, we need to decouple different elements. That's where we are starting having a different type of mini applications that now they need to interact itself and they need to talk between them. And with that interaction, we need to have some kind of contract that make that communication possible. So far, what we have been doing is only front end application. That means it's application that fully JavaScript on the browser side, and it only have the information that is rendered in the browser, and those have the rules, the different keys and elements in order to pull and build the interface that we had it, and we're using Vue as a framework for that. That's why we need to compile it. That's why we needed to build it in order to push it and have somewhere deploy it. Right now, what I have now everything that we have been doing so far, we actually keep it static. What I mean is we put that data per se in the element or in the file itself. You haven't seen when I would refresh the page, the state is not being saved because there's no some kind of database connection or something persistence. We can have probably in the browser side, but we are not doing it yet. And when we start building more complex applications, we need to have that kind of consistency and be able to scale the different pieces to actually put together. So one way to communicate for those tools is through an API design. And I want to talk about like a little practical guide how to build those backend and frontend. So as I mentioned before, we'll be doing front-end applications per se. Um, but at the same time, everything is being rendered on the client, so as I said before, in the browser. That means our connection strings and things like that are important are not even secure because they are actually saved through the front end. Now, if you have a database or backend or way to save clients' data or users' data, you need to have some kind of separation of the layer. And usually those applications called backend. So a backend application is pretty much like an app that have the persistent, the connection to the database, save data back and forward, and then it present that in a layer that our front end is able to understand. And they need to communicate between others. So we actually have two different apps, at least that they can communicate. And that's where we have the API design and how to call that. But just to jump right away to APIs, I want to get back a little bit to talk about network um, and understand where the API and the call actually make sense that they are, right? So for now, the learning goal. For now, we need, in the end of the module, we should be able to explain how HTTP fits in the internal stack and why it matters for API. Read the book Route HTTP requests, design proper RESTful resources, getting the detail right status codes, errors, paginations, things like that. I know that doesn't make sense right now, but we will talk about those later. And finally, getting connected to all the front-end development. So where does HTTP live, right? Before REST, we need a vehicle, right? And the REST is the platform or the type of the language that we will be moving forward and communicate with our backend. But that translates to move it through HTTP. And in the internet stack, what we have with the HTTP is, let's think of this as a mental mode, right? So at the top level, we have application layer where we have elements like the HTML, like websites, like usually we render, where HTTP live, and JSON, where we can actually pull data in a JSON format. We've been seeing that in a while. And it defines what the message means, where everything lives. Now, after that, below that application layer, we have the transport layer. The transport layer is where we have the TCP, where we have the package that is being sent from one node to another, and is being separated in different elements. And the more modern one is actually using the quick protocol. I don't want to go in details about those, but just to know where they are living, it's in the transport layer, where you separate your requests in segments, in fragments, and even sending those. And TCP, one of the things that it does is try to acknowledge that the package was been delivered. If it's not, you just send that package again. That kind of stuff, right? We have reliability, ordering, and retransmission. And then we have the internet layer. And that's where we have the IPs. And routes data across network via IP addresses. And then we have the link layer. That's pretty much at the bottom. That's the physical transformer. It's pretty much the air where the antenna is pulling data, or the actual cable, right, where it's connected through the system itself. So in order to have that, we need to see different elements and understand where we are. So HTTP is on the top of the layer, as you can see right here, and probably we can draw it out. We can have, so we have our client or user in this particular element, and our user will be able to make a request. The request will travel all the way for all these layers. It will move physical to the server, whatever we actually needed, and the response will travel back to our user in the other direction. It start with from the link layer to the internet transport application. And that's pretty much how the requests and responses move through the system. Now, why lower levels layers matters to designers? You design on the application layer, but failures could actually happen in different areas. And that we need to think about it. So if a connection drops mid request, we need to retry that request cause duplicate data. We need to be careful. That's the independency question about the thinking about this element. Let's say, for example, you create a user, but the knowledge of the user creation fails because there's a problem with the network layer. Does that mean that you need to try it again and recreate the user? Then where you have like two users with the same data. We need to think about those in our designs about the layers and what are important. Timeout happens when a packet gets stuck on the routing layer. Could be that it's too big and some of the intermediate process drop it. When you think about those timeout, or when there's something stuck, what we do about those timeout, right? We need to have error handling. Network failure happens, application error happens, so we need to be careful with that. And rate limiting. We need to protect from spam or to flooding on the network. Have you heard those concepts regarding DDoS attacks, denial services attacks? Usually, the way that it works is to have several nodes that sending millions requests per second until it flows the server and the server is not able to handle any other requests. Yeah, so rate limiting will help us with that in order to not to process requests in a specific amount of time that we have. as a key getaway, you mostly design at the application layer, but we need to understand layers below to help handle failures gracefully. So we need to think about the whole step. So let me show a little bit like a request lifecycle, client to server, pretty much. So let's say that the clients here make want to go to API example.com. This will go to our DNS server. The DNS server will say, well, that URL belongs to one particular IP. After the browser knows now that this DNS resolves to this particular IP, we send a TCP handshake to that IP address and we locate the server. So it's pretty much like, hey, are you there? And the server reply, yes, I am. And then we start the handshake for the certificate for the secure connection. And it's a similar step. Okay, you're there. This is my certificate. So, and what you have, okay, and these are my keys, the layer for connection. Okay, now that I have all that, now I can say, okay, give me your product. And the server will process that information. It will do different steps, validations, things I need to do. And after that, we'll just respond with a status code and a payload, a data in your response. So that's the life cycle of a client to a server. So just to understand what it is, because we usually just focus in those in the last two elements. Usually we just focus in this area, like I'm making a request and I get a response. But we need to be aware that this happened before, and we need to be careful regarding those. We need to know where the DNS pointing as an IP address. After we got the IP address, we use that to find the server. Then, if it's a secure connection, we we start the TLS handshake, the certificate, and now that we have all that in place, we can actually start doing requests. So just keep in mind all those different elements. Now, so far we were talking about URLs, but I want to just to understand the different parts of what it means and how it matters for a REST itself. So let me just tell you that URL versus a URI. So URI is in reality an identifier. It is the general concept, the resource identifier. We have URL is a locator, the resource locator. Is a URL is a URI that includes how and where, pretty much. So when we have something like this in this element, we have HTTPS api.start.com version 1 products 42 question mark sort equal price. We will have different elements that we can break out in four different areas. The green part is the schema, is the protocols. The blue area is the server address, that's the DNS entry. The path that we have after that is our resource location. And the query, everything that is after that question mark, usually are the modifiers. Here we send that sort by price. But we can have some kind of price ascendant, price descendant. We can have different keys and values, and we should be able to handle those. So we just need to understand how the URL it is created itself, right? Let me close this. So now that we have that, we know that we need to get in the path section. And I want to talk about a little bit about the best practices about this path or the resources that we're pulling through REST. REST will help us um, get or create different elements. And the best way to represent those resources usually here, is through nouns, not action. And that's really important. So best practices for REST APIs, when we have those kind of elements, it's better to have nouns. So for example, product resources that describe what and method describes how. That's pretty much what it is. So we have a product. We want to get the product. That's this will be in plural usually. If you want to get a specific product, well, we do a change um, resource with product forward slash and the ID products. If you want to see the review for one specific product, a best practice is to have it like that, like products forward slash ID forward slash reviews. The last one, what it tells us, just to understand, we get all the orders that the user with ID 42 has, right? Is the way that we can read it. User 42 orders. That gave me the orders or create an orders for the user that has the ID as 42. What is a pattern that we need to avoid? Verbs. Like we have products on the left, we have get products on the right. That we need to avoid. Like just product itself, and we do a get request. And we will talk about verbs in a bit. So we need to delete this one. We don't use a delete with ID equal 42. Like don't do that kind of pattern. Create user, like it's a verb. Update order, it's a verb. It's a different type of methodology, and that's for other type of communication, usually like TCP and other things. Right now we talk about REST API, and the best way to handle resources is through nouns, no verbs. So we need to keep that in mind in our design. But well, we're talking about HTTP. What about HTTPS, right? The secure layer is pretty much HTTP over encryption. It has identity and integrity. And that will help us because protects credentials and tokens in transit. What I mean, without it, anyone on the network can read your authorization tokens. And we'll talk about that kind of information. So let's say that you are in a coffee shop and you're connecting the free public API for the coffee shop. What happens if somebody you are connecting to a website that doesn't have encryption, HTTPS, anywhere, anybody in that same network connected as you can read the responses because most of the time you're sending those through to the air. So anybody can cache those and see the package. They're not being encrypted. So HTTPS does that for us, encrypts that information, and is the way that is beneficial for everything. So the other thing that we have also is the identity. The TLS certificate helps us to prove that API.example.com is really the server, not an impersonator. So that's something that it could happen. So the certificate gives us that kind of validation that we need. It gives us integrity, prevents tampering with data in transit. And so when it's trying to modify the data mid-transit, TLS will detect it and say like the data has not been encrypted from when it was originated. That means take it as a false information and drop the package. So the bottom line is always use HTTPS. As simple as if it's not HTTPS, assume that somebody can read you or modify your request. The handshake happen before any HTTP data flows. And that's what we saw in the communication in the request diagram previously. When we actually saw that the handshake happened before we get any resource that we need to be using. So you'll be careful through those, right? So, so now we saw how the data layer, we understand a little bit what a request response is. We saw a little bit how they actually set it up and the different variations of the elements of the URL URI identifier and the difference that we have. Now we need to see, well, what is an HTTP request? What is being sent from your browser when you need something, when you click a button or a link. What is happening there? Well, it's usually just a simple text message. Your browser sends like a text document, let's say like that, a text message that have different lines, and every line have a specific meaning. So this is a raw HTTP request. So here is the start line. In this start line has three different parts. We have the method at the beginning. Let's call this. This is the method. We have that's pretty much the verb for here, verb, and hope that it's actually able to read that about what type of request we are doing. And we will talk about the verbs in a minute. Then in there we have the path itself, where we're calling. We see that we have the resource in this case and the query. And at the end we have the HTTP version. There's different HTTP version. We are right now pushing forward to HTTP version 3. Not everybody is there. It's for the new format, but HTTP 1.1 is the normal or the most common, and HTTP 2 is the most common one, right? After the first line, the rest of the line, until we have a space, we have what is called um, headers. In the different headers, metadata about the request is being sent in a key pair value situation. So in this case, we have 6 different headers. We have the host header, the accept, content type, authorization, user agent, and connection. And those have a specific value. So those are there, and this is called the header, and that will define the metadata about the request. After we have a blank line, that will separate our body, is where we have data deploy. Now, because we are doing a push request, we can have a body in the request. Not all the type of requests have body itself. It will change depending the type of request we're doing. In this case, we are sending a JSON object, and JSON usually the most common way to communicate through REST API. We can do through text, we can do through XMLs, but usually JSON is the most common. As you can see in the previous step, we have our content. We're telling the server, well, I'm telling you JSON format, so take this as a JSON. That way we can see that our payload or our body is a JSON object. And here we're sending just a username, email, and an object embedded inside that preference notification is true, right? So this is the raw HTTP request that's been sending to the server. And that's a complete request itself. So seeing that, again, the 3 different parts. The start line, it's always a single line. You tell the server what you want to do and where. That's important. What and where. Second part, headers provide context. The 4 most common one or most important for REST API are the accept, the content type, authorization, and host. That's really, really important. The start line has method, has query, and HTTP version, right? Without that, headers have the metadata itself. And those are the most common ones that we have. And then the body and the payload after a line. And that body payload present are only present with post, put, and patches, and usually absent when we do a get or delete request. And what is that? Those are verbs. And we'll talk about that in a minute. So the methods of the request is this the way that it is. Let's say in this little example, we want to do a get request to our products, and we're telling it sort the price in ascending order and give me page number 2. So a get request with this information, this is how a raw HTTP example looks like, pretty much, right? This is pretty much what it is. Now, if we do a post, you can see that the verb is right here in the beginning. If we do a post, we see that that information change. We have the header, and then we can have some type of body that it will be at the bottom. So just to have like an idea. If we do a put, it can have the body too. Let's do an example here. Let's do, um, I don't know, something like name, right? And that's how your request will look like, pretty much. If we do a patch, we can have a body too. And a delete doesn't have a body. So get and delete doesn't have body. Post, put, and patch, it could have a body. Or it should have a body, right? Now, we know what we actually send into the server in a request. So what is the structure for responses? It's very similar. It's also a text response, where the first line is the status line. The status line gives us the HTTP version response. It gives us a status code, and that's the important one, the status code right here. And then usually a human readable of the status code. 201 in a response mean created. We'll talk about that later. After those, we usually have the headers. Headers with metadata notices the location header telling the clients where the new resource lives, right? It's telling them like, hey, we have a date. It's providing that. I'm giving you back JSON information. That's a content type, and telling you, well, if you want to see this, this is going to be the new location. Let's say like this will be where you live, right? And then we have the payload as a JSON. That's the response. It's telling us the ID is 43, the status success, and the link where that new resource lives to. Yeah? So that will help all the mapping of the three different parts. We have the status line, we have the headers, and we have the body. We need to be aware of those elements. Key teaching point: front-end developers consume the status codes and bodies. Backend developers must guarantee they are correct and consistent. This is the important part. And we'll talk about that. So at the end, we talk about HTTP, we talk about TCP and everything. What is REST itself? In plain English, REST means representational state transfer. It's an architectural style. It's not a protocol. It's not JSON. And it was defined by Roy Fielding in the 2000. So after that, we understand what it is. Is we understand the HTTP and REST travels on top of HTTP. So there's a critical distinction here. REST is not a protocol, it's not a specification, it's not JSON. It's an architectural design, a set of constraints. The name representational state transfer comes from the idea that the server transfers representations of resources state to a specific client. Now, we talk about some constraints, and let me talk about those specific constraints as an architectural style. So one of those is scalability. Your API can handle more load without redesigning it. In other words, you don't need to change your code to handle growth. Simplicity. It should be easy to understand. Developers can understand the use of an API quickly. As we saw before, and when we do a post to the users, what it means for me is I will create a user. So it's easy to see. Evolvability. It can change without breaking. It can evolve to a better functionality or different areas without breaking what is already in place. And separation of concerns. Front end and back end can evolve independently. It will depend in the case. You have in your applications, you need to do more processing in your backend. You can scale the backend without the need to scale the front end, and vice versa. You have more calls that doesn't require that much backend information. You can scale your front end without the need to scale the backend. So it decouple and have that separation, and that's what allows us in the world to have that decoupling, and it's really really good. Now let's talk about a little constraints, and let's see 1, 2, 3 here. Client server separation. The front end doesn't know how the database works. The backend doesn't know what framework the UI uses. They communicate through a contract. That's as simple as that. Client-server separation. The front end doesn't care what type of backend do you have, and the backend doesn't care what type of front end you have. You just have a contract to talk about those. And that's the cool thing. That means that you can switch one of those without affecting the other. Let's say you are using Vue and want to move to React, you can recreate the front end of React and use the same contract to communicate. Let's say that you're using Node.js as a backend and you change to Python, you can do that and just keep the specification of the contract. And everything should work the way that it's supposed to be. That's a really cool thing. The other, and it's the crucial one, and that's really, really important here, it's really crucial, is that the server does not store sessions data between requests. It's statelessness. Every request carries its own authentication token and data. This means any server instance can handle the request. So usually when you have a full-blown application or a monolith application, is the way they call, you have a session that is stored somewhere, and the server knows who you are because that session is stored. Well, in a REST API, you don't save session. Well, probably you do, but it doesn't matter which server you hit. You always will know what is authentication. In this case, we usually send that request data with a token, with a header that represents the token, usually the way it is, that the server that hit it is able to validate, oh, this token is valid, let me proceed and give the information or do the specific task that are being called to do it. So let's imagine a world that your API has 3 different servers as a backend because you grow having 3 servers. And usually the way that load balancing works, it becomes really easy, is that it do some kind of round robin. What I mean is when you do a request to the API, you hit server number 1, for example, and then do another request. Now you're hitting server number 2, and you do a third request, you hit server number 3, and go on. And then 4 requests, it go back to server number 1. That means the state doesn't need to be saved across your servers. So whenever you hit the server number 1, you send it the token authentication, and the server will say, yeah, it's authenticated. And if your request anyway hit another server, you will see the same authentication token and will validate that too. So it doesn't store the session or the state per se. It can be moved, grow without any issue because of that. One core constraint is cacheability. Responsibilities they must save if they can be cached. And there are some headers there like cache control, tags if not matched. I just want to mention those. So whenever they can cache a response, this will reduce your load and improve performance. Imagine that every time that you tell it, you know what, give me product number 10, it will validate and we'll see that 10, it will do a database query, pull the game product number 10. It will then see which information need to be sent. It will prepare the object. It will wrap it up and then send it back. That over time cost. If product number 10 doesn't change, you need to be going to the database every time just to see it. You can say, you know what, like for the, so just an example, for the next 5 minutes, if they're calling for this product, you always be send this product. And it saves in a different place that is a faster retrievable and doesn't need to go all the whole validation and go all the way to the database to pull it. The cache push that information and make your backend lighter. That's pretty much what it is. Now, number 4, uniform interface, REST signatures. Resources are nouns, like products, users. Standard HTTP methods carry meanings, get, post, put, delete, and consistent representation in JSON schemas. It's a layer system. What means your client doesn't need to know if it's taken directly to the server or going through a CDN or load balancer. So you can put pieces in the middle, the way that was mentioned before, and it doesn't matter, right? If you just have a client before that is hitting your server, that's okay. But then if you put a load balancer, your client doesn't need to change. Like it still communicates and the system should work. Now you put a CDN in order to content delivery network. Usually it's used when you store specific image or that kind of elements near your client. So it doesn't need to go to a server to pull it. It goes to a repository to get that type of information. You can have those layered and it should be still working. So that's one of the constraints about this. Now, quick note about the original. Did you look for the original REST documentation? We talk about a HTTP hypermedia engine for application state. It's a great concept, but it's not being used in reality for JSON APIs. So I know that you will research about REST APIs, and you see this term. This is what I mean. It's just rarely used, to be sincere. Now, HTTP methods and CRUD operations, mapping verbs to a database operation. And let's talk about the base. We've seen those already. Get, post, put, patch, delete. So let's connect the HTTP methods to a CRUD operation. CRUD operation is create, read, update, delete. So we need to have two types of concepts, independent and safe. And safe means that doesn't change server state. So the get and the head request verbs is read products for listing, doesn't modify the catalog. Independent method produce the same result no matter how many times you can call it. Repeating the same request reproduce the same state. Important for retries after timeout. That's really important. So, example, you want to delete the product number 42. The product 42 will be deleted and you will not be deleting other products. That's it. It will have the same state after the fact. So it doesn't matter if it's called several times, right? So let's try to understand it. A GET request in the CRUD methodology is a read. It is safe and it's independent. It doesn't have a body, and the typical use is to fetch resources. A post creates new resources. It's not independent. Calling twice will create two different resources. That means the state changes. So we need to be careful with post. Put replies an entire resource. It is independent. That means that, let's say the product 42 is an iPad, let's say, for example, and then you're not selling iPads anymore. You're selling now Samsung tablets, and you want to repeat the product 42. So now your new product for it want to be now an Android type or Samsung tablet, whatever. That's usually the put. It will replace the whole object per se. Patch, partial updates is independent because it will depend on how you implement it. What I mean is let's say that your product 42 again is an iPad and your price was $350, let's say it, and now you update it with the new price will be 400. So you patch just the price element, but the rest objects keys for the object stay the same. So depending how you put it, you need to be careful not to recreate a new object. Use it independent because if you're updating the price several times with the same price, you will have the same response over and over. And the delete removes the resources, independent, deleting something, already deleted, it's still deleted, right? The nuances color out is important. You can make post independent by using an independence key, but we need to talk about that later, like how we can actually be careful not recreate an object twice, right? And there we can use a key or use a patch independency depending with the implementation that we have. But we just need to be careful regarding those. So if a post fails, we need to make sure that we didn't create the object whenever we call the post a second time. That is important. Now, a concrete conversation about put at patch. Put replace the entire resource. It needs to send all the objects, all the fields, Any missing fields will be delete or reset that fields to the default one. For example, here you see my request. It doesn't have headers. We just see that the line at the top is a put request to product 42, and we send in the payload that is the whole object. A patch, as was mentioned before, only sends the fields that you want to change. The rest remain untouched. So that's the difference between put and patch. When to use which? Well, in practice, most APIs prefer patch for updates because clients rarely have the need to complete the complete resource, right? It's really weird that you need to keep a specific ID for a whole new different product. So what happened when you retry? They say that you have network timeout. That's what I was saying before. Without protection, post create duplicate orders. So they say that you send a post to orders, and the service creates the order 101, but the response is lost. The client will say, "Well, let me try it again," and now we have a duplication order. That's the why we need to keep it safe, right? The independent key is a way to do it. We can do it in the backend too. So we will say that we have a post request with a specific key, like this is create the order and store the key as a somewhere. And when we send it back, well, say, hey, that key already happened and it saved it. So let me just return the original order. I don't need to recreate it. That's pretty much what it does. And we can send those through a header, right? Compare as a put, that is a natural independent. If we send put, um, it will always generate the same state. It doesn't matter how many times we call it. So let's put it all together with a practical example. We talk about the good patterns. It should be nouns for collections, IDs for specific resources, and nesting for sub-resources. Avoid, we already talked about those, verbs, inconsistent pluralization, and action encoded in path. Like products forward / create, like, no, let's avoid those patterns. Fetching resources through get is like get product 42, accept application JSON, get a list. To get a list with filtering, sorting, and pagination, we send those to as a query. So we get product with category equal electronic, and sorting equal price ascendant, and page equal 2, and limit equal 25. That will help us for like tables and paginations. It's pretty neat regarding those. The response shape is critical. Recommend 3 top level keys. This could be something that the way that you respond. You can respond with a data. Usually meta, like say like when you have too much information, the meta you say, well, you want a specific page. This is the sizing. This is how many items you have, how many pages exist, things like that. Like this is just a recommended. You can do your response the way that you want it. This is just a good example that you can do in your response as a best practice. And data, meta, and links that will handle that. Why the response shape matters? Well, data is easy to iterate and render in a front-end framework. Meta drives pagination. So imagine you're looking your email and you're seeing, I don't know, 15 emails in the list, and you go to next page, next page, next page. You're not actually calling your backend and pull all the 1,000 emails that you have. You're just pulling the emails that you have for that particular page. And then the front end will read that response and will say, okay, let me put X amount of pagination. I'm I still have a next element. I still have a previous element. So let me put the next and the previous links there. That kind of information. So the meta drives the pagination UI. Links enables navigation without rebuilding URLs in the client side. So that's a good thing because you will give to the user what it really exists on the server and will not let that to be changed on the client side because that then can be tampered in a way. So API responses, data, meta, links, render the products, build the pagination control, and preview next navigation, pretty much. When you need to create a product, we talk about the post itself. It will be like simple request and response. You send the verb, post, the resource, the HTTP version, but you're telling them what type of content you're sending and what type of content you are expecting to have. And you send the product, wireless mouse, price 45. And the response on the same version, the status code in number and human readable, the location, and then it says what type of content is responding, and then give you the data element for that particular product. It got assigned the ID 43 in this particular case, right? Error handling we make consistent for any day one. Like we need to be careful with that. What that means is if we send a 200 as a status code with an error, it's an anti-pattern. Like status code says success, but body says error. It's confusing for clients. We need to be consistent there. So we need to keep the status code the way they're supposed to be. For example, a correct approach, we have unprocessable entity 422. It's really specific. It's really weird that we send 422. I just want to put out an example. And then we, in the body, in the payload, we say what happened. There's a validation error. So we cannot process this particular request. So it is important that when we create responses, those are the type of we need it. I recommended everybody at the same time. We have the error element. You have your code, your message, details, and a trace ID, and then you will keep in your logs. That's pretty much a best practices, and that's something that happened in the real world scenario. Maybe for the cloud, we have a simplified version of this, even and the other objects of response, but I want to keep it like what happened in the real world, usually in that type of calls. The code is machine readable, message human readable, detailed will see what fields fail, map for a form validation, and the trace ID is just for debugging and support tickets. What status code do we have? When everything goes okay, we usually are in the 200 codes. 200 mean okay, the standard success response for every get put a patch. 201 usually is when you post something, includes the location of the header. So when you do post, you usually respond with 201. No content means success with no body, common for the lead operation, right? Then we have the 300. I don't put the 300 here. 300 usually is redirections. So just skip those for now. But then for the 400s, we have the bad request. That means malformed input. Unauthorized, that there's notification token missing. Forbidden, that you are authenticated, but you're not allowed to do it, pretty much. 404 is the most common error that we know that it doesn't exist. 49, we can sustain conflicts. You can have like duplicate email, concurrency issue, version mismatch, things like that. Like it could be like you want to create a user, and then you want to recreate the user, and that email already exists, so you cannot create another user with the same email, something like that. 422 processable is the validation, but file it on business validation. Like for example, price less than zero. You can have price less than zero. Like you need to put that's important. You need to put validation in place. 429 too many requests, rate limit exceeded. It usually includes a header or a retry after, where you say that when you can make the next call, right? And the 500 errors, just internal error. That's something went wrong with your server, like expected server failure. Like for 3, the server temporarily down for any other reason. So usually those are the common groupings of status codes that we use. And this is just a status code decision map. I don't go through that. You can go through it. Like you will try it. If it's valid, you try to check the authorization. If it's allowed, if it exists, if it's a valid rule, and then you can see like promote the decision map, like what response code said on top if something happened, right? So the front end assumes that the backend must be what the backend must guarantee. Consistent JSON shapes. The front end will call against the patterns. Success response. Try to grab data in a data. Error response. Try to grab the error in the error object. As simple as that. Consistency matter. The front end can write one error handler and one response parser for the entire API. Inconsistent shapes, especially case everywhere, is equal to box. So you have consistency, you don't repeat yourself. As simple as that. Status code drives UI logic. So we need to be aware of that. If you have 4.1 error, you need to send the people to login. You have 4.3, you deny that person. You have 4.3.2, you have form error, and you can probably match those form errors with the red or something, and go on, right? There's something also important in the REST API. It's about the course cross-origin requests. This means when your front end and your back end have different origins or different URLs. Let's say even you're running locally in your computer. You can have your front end in port 3000, but your backend in port 8080. The browser automatically will block those requests. So in order not to make that blocked, we need to allow the course for your reading. So we need to say the headers on the backend. You need to say, okay, we need to have the access control allowed, and what content type, what headers we need, and what type of methods we can assume. So you can handle those in your request. So as simple as this, let's say, for example, you do a post to products. Usually the server will set that option first, just to see if post is allowed. It will check course headers, and it will say, yeah, this is the, if everything goes well, yeah, you can proceed and do the post request, and then you create the data. But we need to put that on the backend, and we will see that when we create the backend. Authorization token placement, we'll talk about like frontend sends usually a header called authorization with a key and a bearer token, and the backend validates, extracts that header, verify the signature, extract the user identity, and apply authorization roles in permission. Why? It works across HTTP methods, and bearer token is really good because it's stateless, self-contained, scalable, and standard. So it's pretty neat to have that. So there are different ways to do that. Usually, bearer token is the most common way to handle that type of information. So going back, the full request response lifecycle. We want to get a product and give me from the first page, and I send them, I have this in my authorization. My middleware, usually your server, before it handle the request, you need to validate it. So you check, okay, token is valid. How many requests this user has been doing it? I'm still in the allowed timing to do requests. Okay. API handler, yes, it's authenticated. So the API handler will say, okay, let me do my query to the database. Let me select product from database and limit to 25. That's the default one. It will reply with my result set. It will create my object, my data meta links, my API handler, and then will respond with a 200 OK JSON to the middleware that will send that to my client with my course headers and the JSON file. And then the front end, what it does, render the product list and build the pagination from the meta. That's to understand a little bit. All these elements here we will be doing in one server. Like we will have separate servers for that. Well, the database will be different, but we have the database here, and it will be our server, right? Usually, so we can understand how this call is going to be handled through the process. So, okay, takeaways about this. ATP is a vehicle. REST right on top of it. Understanding the stack helps you debug. REST is about constraints, not specific technology. Resources are nouns, methods are verbs, always. Status codes aren't just numbers, they drive real behavior. Consistency in your response shape is the most important thing you can do for your team when you're working in a team environment. Always design with the front end developer in mind, that your primary consumer. So I hope that you like it. If you have any question, any doubt, don't hesitate to reach me. go through the slide on the link that I will provide, and then you can do and answer the quiz. Let me know how that goes. Meanwhile, I wish everybody a happy coding. See you guys.